before we get into some concepts, let's understand these basic elements, some elements of set theory in a way. So let's assume there's a sample space S. So what is sample space? All the possible outcomes, if a particular experiment is done or some event is happening, etc. So let's imagine this, right? I roll a die or a dice, that's the whole story. So what is a sample space? What are the possible outcomes? You might see 1, you might see 2, you might see 3, you might see 4, you might see 5, you might be 6. These are the 6 outcomes that you could see if I roll a dice, right? So let me define A is an event, event of seeing even numbers, right? So what are the elements in this set? Even number when I roll a die, right? What is the chance of seeing an even number is something like that. 2, 4 and 6. Let me define event B is getting an odd number, right? So what is this event? 1, 3 and 5. Let's say event C is getting a multiple of 3, right? What are the multiples of 3 which could be seen when I roll a die? 3 and 6, right? These are the only 2 possibilities, right? So event A is getting even number when I roll a die, event B is getting an odd number when I roll a die, and C is getting a multiple of 3. So these are the possible outcomes for them. I mean, these are the acceptable or favorable outcomes, and these are all the overall outcomes. So what is the probability of event A happening? As simple as it, there are 3 favorable outcomes. If I roll a die, I can see one of these 6 happening, so 3 by 6, so the answer is 1 by 2. And what is this? P of A bar, it's basically, probability of event A not happening, right? A simple way to look at this is this: the total probability is 1. So if I want the probability of event A not happening, I just have to subtract 1 minus probability of event A happening. As simple as it, right? So probability of A bar is basically saying event A not happening is calculated by using 1 minus P of A. So what is probability of A? That's 1 by 2. So 1 minus 1 by 2 is also 1 by 2 here, but yeah, that's how you calculate this. What is this? A union B. This is union, that is basically A or B. If A is correct or B is correct, I'm happy with it. Or sometimes there could be a chance that both of them can happen together as well. So if you see this A and B, A or B, right? So if I roll a die, if A happens, I'm happy, or B happens, I'm happy. So that's all favorable outcomes. So 2, 4, 6 are favorable outcomes. So there are 3 favorable outcomes. So basically what is A union B? 2, 4, 6, 1, 3 and 5. All the 6 elements are coming into this now. So favorable is 6, by 6 is 1. So the probability of A union B in this case is 6 by 6, that's why it's 1. So either I get a even number or odd number, right, when I roll a die. So obviously that is what I get. Let me do it for P of A, rather B union C, okay. Let me talk about this. So either B or C happens, I'm happy. So what is B union C? What are the set elements in the B? If I get 1 or 3 or 5, C is 3 or 6, 3 is already written, so I just need to write 6 extra. So 1, 3, 5, 6, there are 4 favorable outcomes and 6 is the total possible outcomes. The probability of B union C is 2 by 3. So what is this? Intersection. Intersection is basically AND. I need to see both happening. That is, A has to happen and B has to happen. A union B is basically picking the common elements in both the sets. There is no common element. If you see 2 is here but it's not here, 4 is here but it's not here, 6 is here but it's not here, 1 is here but it's not here, 3 is here but it is not here, 5 is here but it is not here. So A union B is a null set. There is nothing in this. So it's basically 0 by 6. That's why it is 0. Right? Let me show example like probability of B union C. Sorry, intersection C. So B has 1, 3, 5 and C has 3 and 6. So what are the common elements? I see 3 is the common element, right? So that is basically it will have one element, that's 3. So P of B union C will be, sorry, this is just B union C. P of B union C will be 1 by 6. That's how I do it. Right? This, what about this? P of A bar union intersection B. That means not A or B. So what is not A? So if A is this, what is not A? That is basically whichever is the total possible outcomes minus A will give me. So I just have to remove 2, 4, 6 from this. So I'll have 1, 3 and 5, which is equal to this actually. B is also same 1, 3, 5. So what is P of A union, like A bar union B? Needs to pick all the elements, unique elements 1, 3, 5, and I see again 1, 3, 5. So the unique elements are only 1, 3 and 5. You see, union is basically picking the unique elements 2, 4, 6, 1, 3, 5. So I've got all the 6 because each one is unique in both the sets. Intersection B is when an element is present in both the sets, then only I have to pick it. That's why 3 is the only thing that's repeating. That's why I selected 3 here. So P of A bar union B is 1, 3, 5. So this will be 3 by 6. That's 1 by 2 again. Then P of A union B union C. As I said, union is pick all the unique elements in all the 3 sets. See, A has 2, 4, 6. B has 1, 3, 5. C has 3 and 6, which are again repeating. So the only unique elements of A union B union C is 1, 2, 3, 4, 5, 6. Basically all 6 are coming. So it's 6 by 6 is 1. That's why the answer for this is 1. You know, this is how you have to understand this at a very basic level. That will solve some problems, some questions again and again on this so that you get this understanding better. But this is how you have to do, you have to understand. I mean, you don't have to, or you might not get situation where I can keep elements being listed like this and so that I can do this properly. But fundamentally what we are doing is this. You understand this logic. These are the total outcomes. So these are the respective favorable outcomes. So what is A union B, what is B union C, etc., intersection, etc., A bar. Then you should be able to do questions based on this easily. So there is one theorem on this called addition theorem. So I can do P of A union B is basically P of A plus P of B minus P of A intersection B. I'll just show you in the case, right? What is P of A union B? 1. What was P of A? P of A is 1 by 2. Similarly, P of B is also 1 by 2. What is P of B? B is 1, 3, 5. There are 3 elements out of 6. That's also 1 by 2, right? There is also 1 by 2. Minus P of A intersection B. What is P A intersection B? Which I have done here. A intersection B is 0. Right? So I do minus 0. So half plus half is 1 minus 0 is 1. That's equal, right? This is correct. Let me show it for this also, right? P of B union C, which I have done, is equals to P of B plus P of C minus P of B intersection C. What was P of B intersection, union C? I have calculated this to be 2 by 3. What is P of B? Half, right? P of B is half. What is P of C? There are 2 favorable outcomes, 3 and 6. So it will be 2 by 6. That's 1 by 3. So I have to do 1 by 2 plus 1 by 3 minus P of B intersection C. What is P of B intersection C? 1 by 6, right? So that is minus 1 by 6. So I will take the LCM as 6. So this will be 3 plus 2 minus 1, that is 4 by 6, that is 2 by 3, which is the P of B union C. Right? That's how you can apply this. Based on what's given and what's not given, you can find one of these 4 elements. Right? Most probably you should be able to playing around with this. They'll give you one of these 2 or maybe some clues to find out one of these 2, and these could be also calculated so that you can find the remaining value. For a bigger, like if I have A union B union C, it is P of A plus P of B plus P of C minus P of A intersection B minus P of B intersection C minus P of A intersection C plus P of A intersection B intersection C. If you see earlier case, P of A union B union C was 1. Right? P of A is 1 by 2, P of B is 1 by 2, P of C is 1 by 3, P of A intersection B was 0, P of B intersection C was 1 by 6, P of A intersection C would be, A intersection C, as I said, would be, as you know, A is 2, 4, 6 and C is 3, 6. Pick the common element, that is 6. Right? Again, P of A intersection C would also be, there is one element by total 6 possible outcomes, so 1 by 6 is the probability. So this is also simply 1 by 6 and this is 0. A union intersection B intersection C, picking the common elements. What is A? 2, 4, 6. What is B? 1, 3, 5. And what is C? 3, 6. You see, none of the elements are appearing in all three. So A intersection B intersection C is 0. So 1 by 2 plus 1 by 2 is 1, plus 1 by 3 minus 1 by 6 minus 1 by 6 is minus 1 by 3. They get cancelled out. I'll get 1, which is what this is, right? So these two, this is mostly used and seen. This is a bit rare, or very rare, to be very frank, but still good to think to know. It's just this, right? A plus B plus C minus intersection 2 intersections and plus 3 intersections. This is A plus B minus A intersection B. It's the same format. I see minus for two, 2 elements intersection. For the 3 elements intersection, I'll see again plus. So let's get to this. If A and B are 2 events in a sample space such that probability of A is 2 by 5, probability of B is 1 by 3, and probability of A intersection B is 2 by 15, and P of A bar intersect union B is 8 by 15, then find the respective things, right? What is P of A union B? Simple. What is P of A union B? P of A plus P of B minus P of A intersection B, right? That is what the addition theorem says. What is P of A? 2 by 5. P of B is 1 by 3. P of A intersection B is 2 by 15, so I have to subtract that. Take the LCM 15. 2 3s are 6 plus 3 5s are, so 5 minus 2. So that is 9 by 15, that is 3 by 5 is the answer. Right? That's how you do it. Now, let's look at the next one. It's asking P of B bar. P of B bar is, as I said, simply 1 minus P of B. 1 minus 1 by 3, that's 2 by 3. And what is P of A bar? I'm just calculating it here. 1 minus P of A. 1 minus 2 by 5, that is 3 by 5. That's how you do for the bar. P of A bar intersection B, right? It is basically asking me what is this value. Think like this, A bar is a complete element, right? So what am I saying? If I am trying to find what is P of A bar union B, that's basically P of A bar plus P of B minus P of A bar intersection B, right? Right, like if I take this entire thing as C, I am asking you to find what is P of C intersection B, which could be done by using P of C union B is P of C plus P of B minus P of C intersection B, where C is basically A bar, right? So they are asking us to find this. I know what is this. They've given us P of A bar union B is 8 by 15. So 8 by 15 is equals to P of A bar is what I've calculated, 3 by 5. P of B is calculated as 1 by 3 minus P of A bar intersection B. This is what I need to calculate. So I get this side and this goes this side. So P of A bar intersection B is 3 by 5 plus 1 by 3 minus 8 by 15, which will come out to be by 15. 5 3s are, so 9 plus 5 minus 8. So that is basically 14 minus 6 by 15, which is 2 by 5. Right? So all we have done is use the same formula, this formula. First question they gave us this and this and asked us to find this. In the last question they gave us this and this and they asked us to find this, which I can do, right? Same thing. So this question is also very similar to the A union A intersection B. It's just that you have to define the events properly so that you can see that in that way. So I have two unbiased dice which are rolled together. Find the probability that both the dice show the same face. So if I define event A is, basically getting same face in both the dice. Right? What are the possible values? I get 1 1, I get 2 2, I get 3 3, I get 4 4, I get 5 5, I get 6 6, right? So there are 6 possible outcomes which satisfy, this same face part. Let me define event B is getting sum to 8, right? 2 dice show me whatever the number such that the sum is 8. How would that be possible? 4 4, 5 3, 3 5, 6 2, 2 6, what else? I can't do 7, 1, 1, 7, etc. Right? So these are the, I see 1, 2, 3, 4, 5 possible cases. Right? So this is A, this is B. So what is probability of A? So what are the possible outcomes, total outcomes, total possible outcomes? If I roll 2 dice, if you understand this, this is like 1, 1, 1, 2, I can get 1, 6, 2, 1, 2, 2, and so on up to 2, 6, and this is like 6, 1, and so on up to 6, 6. So totally I have 36 possibilities, right? 6 in first die and 6 in the second die. I can see 36 different pairs as the possible outcomes. So what is probability A? 1, 2, 3, 4, 5 and 6, 6 by 36. Probability of B is 1, 2, 3, 4 and 5, 5 by 36. What is the question asking? Find the probability that both the dice show the same face or sum up to 8. That is or, right? So it's basically asking me to find P of A union B. Getting same face or getting sum up to 8. So A union B, which could be done as P of A plus P of B minus P of A intersection B, or I can do even directly, right? I know this set. So what is A union B? I'll just show you that. What is A union B set? When I say union, I need to pick all the unique elements. 1, 1 is unique, it's not repeating here, so I'll take this. 2, 2 is unique, 3, 3 is unique, 4, 4 is repeating, so I'll take only once. I would not count this in that, right? 5, 5, 6, 6, then 5, 3, 3, 5, 6, 2, 2, 6, right? Altogether I have 10 pairs. So the probability of P of A union B could be directly calculated as 10 by 36 from this set concept. If I am trying to use this formula, the addition theorem, what is P of A intersection B set? Intersection B is pick the element which is appearing in both the sets. It's only 4, 4, right? 4, 4 is the only set which is appearing in both the sets. So there is only one such occurrence of A intersection B. So what is probability of A intersection B? 1 by 36. So probability of A is 6 by 36, probability of B is 5 by 36, probability of A intersection B is minus 1 by 36. So this will be 10 by 36, which is what we got. See, these problems are done in this way, very detailed manner, only to explain the concept better. Obviously, you don't have to do it like this. The way to solve the question much faster is just looking at these sets and directly coming to this point. You can get the answer in a couple of lines if you understand this concept better. But we are doing this in depth to explain you and make you understand these basic concepts well. How to do intersection B union B, what are they fundamentally meaning, right? So that you understand them better. So let's solve the problems to understand these concepts better. As we always recommend, pause the video, try every question on your own, give a good shot, and then you can look through our explanation and understand this better. A natural number is chosen at random from amongst the first 100. So the sample space is selecting one number out of all 100. So that is, I could select 1, 2, 3 and so on up to 100. What is the probability that number chosen is divisible by 2 or 5? So let me call A, event A is selecting a number divisible by 2. What are those? 2, 4, 6, 8 and so on up to 100. Event B is selecting a number divisible by 5. What are those numbers? 5, 10, 15 and so on up to 100. So what is the question asking me? What is the probability that number chosen is either divisible by 2 or by 5? Event A has to happen or B has to happen, right? Select a number which is divisible by 2 or divisible by 5. What is the probability of A happening? How many numbers are there in a set? 2, 4, 6, 8 up to 100 is 2 into 50 is 100, right? So basically 50 elements. 2 1s are 2 250s are 2 2s are 2 3s are 2 4s are. So basically 50 by 100. So half is the probability of selecting a number divisible by 2. Similarly for B, 5 1s are to 5 20s are. So there are 20 elements here. So that's basically 20 by 100. That's basically 1 by 5 is the probability. Now let me talk about what is the probability of A intersection B. First let me talk about what is A intersection B. As I said, pick the elements which are common in both, which are repeating in both. What is the first element? Such that element 10, right? 2, 4, 8, 10, so on. So that's basically LCM of 2 and 5. 10, 20, 30, so on up to 100 are seen in both. So how many of them are seen? 10, 20, 30, 10 ones are to 10 tens are is 100. So basically there are 10 elements. So P of A intersection B is 10 by 100, that's 1 by 10. Now I need to find this P of A union B. That's simply P of A plus P of B minus P of A intersection B. So that's basically 1 by 2 plus 1 by 5 minus 1 by 10. I'll take an LCM of 10. So it's 5 plus 2 minus 1 is 6 by 10. That's basically 3 by 5 is the answer. Right? That's how you solve this question. Obviously, yes, you could also do things like this. There are 50 numbers which are divisible by 2. There are 20 numbers which are divisible by 5. I just need to, I have double counted the numbers, right? In 10, 20, all of this. So I just need to subtract those double counted, because in multiples of 2, which are these 50 numbers, I am counting 10, 20, 40, 60, 80, 100, which are already counted here 10, 20, 30, 40 again. So those 10 which are repeatedly counted twice in this, I am removing. This is what is basically intersection P. That is what we are doing in all of this. 50 plus 20 is 70 minus 10 is 60. So simply I can do P of A union B is 60 by 100, which is what we have done here, like fundamentally, right? That's how you can solve this question.